When we ask you to find the domain, it says, can you tell me what the domain is? What we asking for is the set of all the values that the independent variable can have. Can you tell me the set of all the values that the independent variable can have? I'm going to leave a space here in a second, leave a space by color lines. But let me write this question here. Y equals 6x plus 7. My independent variable here is x. Can we use any value for x and get an answer? Yes. So in this case, my domain is all real values. Any number that you choose, you will have an answer. Let me try this example. Y equals 7 over x minus 3. What's the domain? Can we use any value for x and still get an answer? There is one value for x. That's a problem for us. Which value is that? There's a value for x. If you plug it in, you will not have an answer for y. What is it? 3. Sure. So in this case, the domain x cannot be 3. Any number but 3. Let me try another one. I left a space for a reason. Y equals the square root of x. What is the domain there? What is it? Yes, x cannot be less than 0. That's the answer I got. Which means your domain, the x value, has to be greater than or equal to 0. Because if x is a negative number, what would you have for an answer here? Imaginary value. Remember the square root of negative number? So when I left this space, that's the set of all the values that the independent variable can have. And here's my restrictions. Restriction number 1, no division by 0. You can't take any number, you can divide it by 0. And the other exception is you can't take the square root of a negative number. No imaginary values. So you got to look for, do I have a fraction? Yes, if you do have a fraction, make sure the bottom of that fraction could never be 0. These are your exception. If you have a square root, make sure the value under the square root, it's never equal to a negative number. Let's try another example with the domain here. What's the domain here? What is it? All real numbers. Any number you plug in here, you will have a y value for it. I don't care how big, how small that number. So you can choose any number and get an answer for it. On the other hand, if I have y equals x minus 5 over x squared minus 4, first, the x squared minus 4, can I factor that? Isn't that x minus 2 times x plus 2? That's the difference of two squares. So what values we can't use for this one? X cannot equal to what? Positive or negative 2. That means any number but these two numbers. That's your domain. Let me try it. F and G. Y equals the square root of x minus 7. What's my domain? You want to make sure the value under the square root is what? Cannot be negative. It's 0 or higher. So you want x minus 7 is greater than or equal to 0. Which means what? X will be greater than or equal to 7. Let's try the last one. How is this problem different than the one before it? What's the difference between them? What is it? Correct. It can't be 0. So you want x minus 7 to be greater than 0. Can't be 0. You can take the square root of 0, but the fact this is in the bottom, square root of 0 will be 0. When you divide 6x by 0, we got a problem. So it can't be. That's why this one says greater than, this one says greater than or equal to. So x will be greater than 7. So that's how we find the domain. Well, how do we find the range? The range is not really that easy. Sometimes you have to graph to see it. Because if you don't have a picture in front of you, it's tough to find what the y value is. So the domain is the values for the independent variable. The range is the set of all values that the dependent variable can have. Can be or can have. And again, if you have a picture in front of you, it's not bad. If you don't have a picture, we got a problem there. So if I have this problem, y equals x squared minus 2. Again, if I graph that one, that's a parabola. Has a y-intercept of negative 2. Looks like this. What's my domain? What's my range? I'll do both. What's the domain? Is there any x value that we can't use here? So it's all real numbers. What's my range? Where is the y value going from where to where? What is the smallest y value that you see there? I see this point. And what's that value? Negative 2? And what's the largest y value that you see? Infinity. The range y is greater than or equal to negative 2. It's going upward from negative 2 all the way to the sky, to infinity. Y equals the square root of x. Again, there's the graph of it. So if you have the picture in front of you, oh, I got it now. It looks like this. And it keeps rising. The domain will do both, and the range. Let's look at the x value. The x value starts from where and goes to where? Starts from 0, and it goes all the way to the right. All the numbers on the right. What about the range? Starts from 0 and it goes all the way up to infinity. So the domain x is greater than or equal to 0, the range y is greater than or equal to 0. Let me try another one. Anyone knows what the graph, the absolute value looks like? Yes, V shape, correct. It's always a V shape. So if you have f of x equals the absolute value of x plus 2. Again, to graph that, x plus 2, it will look something like this, the graph. It's a V shape. So what's my domain? Is there a value for x that if you plug it in here, you will not have an answer for it? Can you think of any number, if I replace x with that number, I will not be able to solve for f of x or y? No. So it's all real numbers. Let's look at the range. That's the y value. What is the smallest y value that you have? 0, and it grows. It gets bigger. So the range y is greater than or equal to 0. Okay, I think you get the idea of range and domain. Let's finish this section. There's a few more topics. And maybe I wish they put this piece actually in the previous section. But let's say you have a function that consists of two parts, not one part. Has a name. It's called piecewise function. So I might have f of x equals, I don't know, I'll do like this, x squared for x less than 0 and 2x minus 1 for x greater than or equal to 0. So if I graph that, if I didn't have the bottom piece, if the question was just like this, without this, f of x equals x squared, just like that, then my graph will look like, well, it will be a parabola, but will look like what I'm graphing right now. Will look something like this. If I didn't have the rest of the stuff, if it was just f of x equals x squared, it will look just like that. But now what they're telling me, you can only use this when x is less than 0. Not even equal to 0, less than 0. So I need to take my white out now and erase all of this. Up to here, and I have an open circle here because less than doesn't say equal to. So that's my graph with an open circle right there. And what happens after x is greater than 0 or equal to 0? I have 2x minus 1. If you graph 2x minus 1, it will look something like this. But again, this function is only good for what? X is greater than or equal to 0. So I need to erase all of this and starts with the 0 that's included here. That's a closed circle, and it goes to the right. So you have two functions to write there, or to graph. And you need to just have white out and erase the pieces that you don't need. This one's only good for x less than 0. This one's only good for x is greater than or equal to 0. So this is the graph of this function now. Where people get in trouble when the book says, can you tell me what's f of negative 2? Now they're not sure which one of these pieces to use. Which one would you use? The top or the bottom? Let me try again. The top or the bottom? Why the top? Because is the negative 2 less than 0? So you have to use the top. If I ask you f of 0, which one do you use, the top or the bottom? The bottom, because the top does not equal to 0. It's less than 0. This one's 0 or higher, you have to use this one. So that would be what? 2 times 0 minus the 1, which is a negative 1. If I ask f of 2, which one do you use, top or bottom? Bottom. 2 is bigger than 0. As long as bigger than 0, I got to use this one. Oh. Which is 4 minus 1, is that 3? If I said f of negative 5, top or bottom? Top. Why? The negative 5 is less than 0. I have to use the top. So that is 25. Sometimes people say, where do you come up with these problems, the functions? Like, I don't know why we're looking at them. Here's an example here. I'm going strawberry picking. And the person says, hey, there's a cardboard just like this. 11 by, what is it, 8? Sheet of paper. It's 11 by 8. I want you to make your own box and go start picking strawberries. Well, I need to make a box out of it. Well, how do you make a box out of a sheet of paper like this? This is, again, 11 inches by 8 inches. So what do? We come and cut a corner from each end, and we fold the edges. Now, I'm not sure how high is it. We'll call it X. How high the box, unknown to us. And when you cut these 4 pieces, there we go. Cut them out. Cut this piece out. Gone. Cut this one out. One more corner to cut. Cut this piece out. And if you fold that sheet of paper now along the edges here, you have your box. I don't know if you can see the picture on the screen. Does it show up actually when you fold it? We're making progress. Here we go, here we go. The box almost done. It's going to hold a lot of strawberries in it. And here's my box. Can you see it? It's hard to see, huh? But we got a box here. Well, what's the volume of this box? I can take actually this sheet out, maybe. You'll see it better. So you attach the corners and you have a box. There's a thickness to it and everything. Well, if you look at the math behind that, trying to find the volume of the box, we had a sheet of paper. It was 11 inches by 8 inches. We cut that little piece out. And if you recall, we called that distance x, we called that x, each one. So now, what is the length of the box? The length of the box now is that distance, which is what? What is it? How do we know it's 8? Here's the box. We took an x out of each end. We took an x out of each end. It is 11 minus 2x. Whatever x is. I have no idea what x is. Some people might decide to make the box Kenyan tall. And the width of that will be what? 8 minus 2x. So the volume of the box now, volume of rectangular box there, is length times width times height. What is my length? 11 minus 2x. What's my width? 8 minus 2x. And what is my height? When you fold that piece, how high is it? Notice I cut it x. When you fold, isn't that the height? Just x. That piece becomes your height. Notice that x, now when you fold it, that's your height. And now that's the volume as a function of x. You give me a value for x, I'll tell you what actually the answer is. Multiply them out if you want to. That's 88. If you FOIL it, 88 minus 22x minus 16x plus what? 4x squared times x. 4x squared times x is 4x cubed. What's negative 22 minus 16? Is that 38? I always like to write my answer in descending power. So that's the volume as a function of x. By the way, for this example, what's my domain? Can x be any number? What is it? Has to be greater than 0 and less than 4. Because if the height is 0, do you have a box? No. And why 4? What's the width of the paper? 8, right? If you fold it in half, you just go like this. There's my box. Fold the paper in half. Isn't that 4? So in this example, that box will have to have a height between 0 and 4 inches. If you make it 0, it's a flat sheet of paper with no height. If you make it 4, it's a skinny piece of paper standing up with no base to it. So somewhere between, that's what x should be. But we use that stuff in multiple examples, functions. We use them from business. Some people remember economics, demand, supply. The equation X to represent the number of items produced or sold. We use them in height of an object above ground in physics, mass, whatever you want it to be.